Okay, I saw this question on the internet. It wasn't written this way, but it was from a guy called, excuse me, Black Pen, Red Pen. Unfortunately, the video that he had associated with the thumbnail is not available except to paid subscribers. So I thought I'd give it a try. The question I saw in the thumbnail was this one up here. So it's 0 to 2 pi. And then I saw 1 plus e to the sine of x dx. And that's what I saw. And then I figured, how do you do that? And I took a few attempts at it. And first thing I said, I wonder if U substitution work, and really unlikely, but you give it a shot, see if you see something, but I didn't see anything. And then I started thinking about it. And what I started thinking about was the sine of x between 0 and 2 pi. So I thought, what does the sine of x look like between 0 and 2 pi? And what it looks like this over here. Right, so it's going to be 0, this will be pi, that'll be 2 pi. Right, then I started thinking that this section of the curve over here is really the same thing as this thing, but it's its opposite. So what I did was I rewrote the integral in terms of two integrations. So let me write this down for you. So I wrote down 0 to pi, 1 plus sine. I'm sorry, not sine. That's not what they said. Let's start again. 0 to pi, 1 plus e to the sine x dx plus, the next one's going to go from pi to 2 pi, 1 plus e to the sine x dx. Then I carefully looked at this with my understanding about this curve over here. And all I did for this, I said, well, I just got to go between 0 and pi now and take the opposite of sine. That's what I wrote down next. Let me dot for you. So I said this is equal to 0 to pi, 1 plus e to the sine x. Then I said this is really the same thing, the second integration from 0 to pi of 1 plus e to the minus sine x dx. Right, now, again, I want to point out that's what I want, so I took the opposite of that, and that's what I'm getting if I stick between 0 and pi. And then I look at this thing over here, and again, you might say I'm stuck now too. It doesn't really make any help. Both of the integrations look impossible for me to do, by the way. So I kind of looked at it, and the next thing I did was I didn't like the negative exponent. I'm going to go to the key and show you where this stuff is written, by the way. So I just, the original integration was presented, split into two different integrations, and then notice that this is the step we're at now. Then what I did, I multiplied the top and the bottom by e to the sine x. And what do you get there? Well, you get e to the sine x. Now, if I did this times 1, I'd get e to the sine x. But this times that would be e to the 0, which is just 1. So then what I do, I took those two integrations, they had the same limits, by the way, and just added their integrands together. They both have the same denominator. And just add this together, what do you get? You get this over here. Now, granted, someone said, how did you get pi? Let's go through that. That's going to be 0 to pi. That reduces to 1 dx. What's the antiderivative there? X. And you're evaluating from 0 to pi. So what do you get? Pi minus 0, which is pi. All right? They also provide a graph for you. The graph really is not helpful, by the way. I just want to point out it does visualize nicely. And this area over here is exactly pi square units. And we're done. Thank you.